So basically, I'm going to take 4 different AI models, ChatGPT, Gemini, Grok, and Claude, and I'm going to give all of them the same problem with the same wording without any hints or help. And then I'm going to compare what each of them come up with. So the problems come from Project Euler, which is a collection of math and programming challenges that get extremely difficult as you get to the higher level questions. The interesting part is it isn't just about who gets the right answer. It's how they think differently and how 4 completely different models can come up with unique solutions that are tested on efficiency, accuracy, and understandability. So here's the problem. You're given a 15 by 15 grid of numbers and you need to pick exactly one number from each row, but no 2 picks can share the same column. So 15 picks in total spread across all 15 rows and 15 columns. So if you know chess, it's like placing 15 rooks so none of them can attack each other. And the actual goal of the problem is to make the sum of your picks as large as possible. So your first instinct is probably like, this is a simple question, right? Just take the biggest numbers. But that might not actually be the case. So the issue is the scale. The number of valid ways to make these picks is actually 15 factorial, which is almost 1.3 trillion. So checking all of them just simply isn't realistic. You need an actual strategy that avoids looking at most of these combinations while still guaranteeing you find the best one. So here is the problem that I'm going to start out with, which is problem number 345 of Project Euler. I'm going to give the same problem to all 4 of the different models. So this is Claude and the same prompt for all of them. This is Grok, Gemini, and ChatGPT. Now I'm going to observe. Each of them are going to thinking, and each of them are going to create their answer, and then I'm going to present and evaluate all of them based on a couple of criteria. So Grok did exactly what most of us were thinking. It went with the obvious approach, which is find the biggest number in the grid, take it, block it off, and repeat it 15 times. So if you watch it work, it grabs 962, the largest value available, then 943, then 623. And every step, it just takes the best thing it can see. And the final answer it got is 13070. But the correct answer is 13938. Grok missed it by 868. And here's why. When you grab the biggest number, you lock out its entire row and column. And sometimes the better overall solutions needed those cells for other picks. The greedy choice looks good in the moment, but blocks combinations that would have scored higher in total. This is the textbook failure mode of greedy algorithms. The best local choice isn't actually the best global choice in many cases. So it's worth noting that this was the fastest solution of the day at 0.1 milliseconds, but it just doesn't matter because it's actually wrong. So ChatGPT took a completely different systematic route. Dynamic programming with a bitmask. That may seem arbitrary, but the idea is pretty simple. Imagine 15 switches, 1 per column. A switch is on if that column has been used. And any pattern of on-off switches is called a state. And there are 2 to the 15 states, which is about 33,000. That's a pretty large number, but it's nothing compared to the 15 factorial or 1.3 trillion original states. So ChatGPT uses this to build a table with 1 entry per state, the best score achievable when exactly those columns are used. Then it processes the grid row by row. For each row, it tries placing the pick in every available column, updates the table whenever it finds a better total. By the last row, the state with all switches on, which means every column used, holds the answer, which is 13938, which is the correct answer. So the catch is actually the speed. It took 80 milliseconds, which is the slowest answer of today. And it scales pretty badly. Each extra column doubles the number of states. So at 30 column, you'd be past 1 billion. So it works here and it's much better than the 1.3 trillion brute force, but it's still pretty slow in the grand scheme of things. Gemini recognized something the others completely missed. Matching rows to columns for maximum total value is called the assignment problem, and it was actually solved in 1955 by something called the Hungarian algorithm, which means it finds the guaranteed optimal matching in n cubed time. So for this grid, a few thousand operations instead of trillions. Picture rows on one side, columns on the other. Every possible painting scored. The algorithm locks in the best set of pairings one by one. And that's what you're watching here on screen right now. Each gold edge is part of the optimal matching. But the real story is what Gemini actually wrote. It didn't implement the algorithm. It knew Python's script library has it built in. So one function call, the whole solution is 3 lines. Answer 13938, which is correct in 0.3 millisecond, which is the fastest correct answer of the day. So sometimes the best move is actually finding something that already exists and modifying it for the current problem. Claude built something completely from scratch. So think of how a chess player evaluates moves. They don't calculate every possible game and every possible line. They just look ahead and see when a line is clearly losing, they stop considering it. Claude explores something similar. The picks is a tree. Choose a column for row 1, branch. Choose a column for row 2, branch again. But before going deeper into any branch, it computes a quick estimate. If every remaining pick went perfectly, what's the absolute best this branch could reach? If that ceiling is below the best answer they've already found, the branch is dead, just skip it entirely. And that's what the red flashes are. Entire sections of tree are being eliminated without ever being explored. One early cut can remove millions of combinations at once. So the answer is correct at 13,938 in 1.8 milliseconds, which is a bit slower than Gemini, but Claude didn't call in a library, it designed a complete pruning logic by itself. So of the 4 solutions, this is the most unique and clear solution. So side by side, we can see in a log scale, each step is 10 times slower than the normal step. Grok at 0.1 milliseconds, fastest but wrong. Gemini 0.3 milliseconds, correct and only 3 lines of code. Claude 1.8 milliseconds, correct but built by hand and the most original of the solutions. ChatGPT with 80 milliseconds, correct but 44 times slower than Gemini with a method that kind of falls apart on larger grids. So 3 correct answers, 1 wrong, but very different ways of getting there. Now, the final verdict. The winner comes down to Gemini versus Claude, and it depends on what you actually value. Gemini is the solution you might want to choose at work because it recognized the problem, used the proven tool, and ships only 3 lines of code. But Claude is the more impressive piece of logic and reasoning, a hand-built algorithm that nearly matches the library speed. So I think in the end, I'm going to give it to Claude for the uniqueness of the solution. Knowing a library exists is simply knowledge, but constructing branch bound from scratch is understanding. So reasonable people can disagree, and I do believe that in some cases Gemini is the best, but clearly the worst is Grok. And not because the code was actually bad, it was one of the most easy to understand logics, and the code was given in an extremely clean manner. And of course it was the fastest solution, but unfortunately it was the wrong answer using a strategy that doesn't actually work. So the answer to the Project Euler question is 13,938 as 3 of the models have demonstrated. So same 4 models next time, but different problems.